Hello guys, it's Sébastien Doyer and today I will teach you how to create your own AI agent using LangChain. So in this project we will create an agent able to find information using your PDF files. So let's dive in.
Okay guys, so to start this video, I want to show a quick demonstration of my agent using RAG and a local LLM, and I will show you my front end for this application. So first I run the Python file main.py, which is a file for automate the launching of backend and frontend. It asks me if I want to repopulate my vector database. I have some document inside my database, so I don't have to repopulate it. So no. Okay, and now this is my front end. So I can ask a question. For example, what is deep learning? It sends the question to my backend. So it is my AI agent. And the agent will answer to this question using my document I have in a folder and the document inside the vector database. Okay, let's ask another question. So what is, for example, batch normalization? Okay guys, so now let me explain how RAGs work. So it is divided in two parts. The first part is the embedding part. So we have PDF stored inside the folder, and the first thing we will do is to create chunks of text, like sentence, like paragraph, and we will transform this into vectors using an embedding model. The goal of the first phase is to populate the vector database we will use just in the phase 2. For the phase 2, the user asks a question. We will use the embedding function to create also another vector, and the goal here is to ask the vector database if there are some vectors close to the vector associated to the question. If there are some vectors, like this, we will use the chunks associate, the chunk of text associate, and the creation to create a context, and we will give to the LLM the context. So the LLM will answer the question using the document we have in the folder. Okay guys, so now let's dive into the code part of this video. So the first thing is the embedding part of the project, and we need to firstly do the loading part of the document. So I use a function called PyPDF directory loader from LangChain because all my documents are stored into a folder. When I create the load document for loading my PDF, we can go into the next step, which is transform the document into chunks. So to doing that, I use also another function from LangChain, which is a recursive character text splitter. So this is an example. This is one sentence extract from a PDF. I am Seb Doyer, a software developer specialized in AI. My arguments for the recursive character text splitter are an overlap, which is at 10, and a chunk size at 20. So for the first chunk, I will take 20 characters from the sentence. So I am Seb Doyer, with a S. For the second one, I will take 10 characters from the previous chunk and also 10 other characters from the sentence. So we have a chunk size equal to 20. Doyer, a software, D, and something. So you get the idea of the recursive character text splitter. Okay, so this is how I use recursive character text splitter into my code. So I define a function named split documents. I give to this function the argument which are a list of documents, and I create a text splitter with the recursive character text splitter. I give the argument for the chunk size, for the overlap, and how we calculate the number of characters. which is with the function len, and I use the text splitter to split my document into chunks. So after that, we need to calculate ID for chunks. So basically, this function calculates ID chunks or create IDs for each chunks, which is the page index and the chunk index. Just before speaking how we add the data into the vector database, we need to create the get embedding function. So this function will call an embedding model, which is for us the nomic embed text. It is free and it is run locally with Ollama. So I use the Ollama embedding from the LangChain library. So this is the add to chroma function. It is the function responsible to populate the vector database. So in this function, firstly, we create the vector database, which is chroma. As an argument, we give the path for the persist directory, which is where the vector database will store the vectors. We calculate the ID for the chunks. After that, we will populate the vector database with chunks which are not already inside the vector database. And to check that, we will use the ID from the chunks. Okay, so now let's work on the second part of the RAG. So this is an example. Let's say we work in 3 dimensions. This is not true because we work in vector space, but this is just for visualization. Let's say we have our vector database here with some vectors in yellow, red, green, blue, etc. Let's say this is the query. So we will take the two vectors which are very close to the query, and we have to use those chunks associated to the vector because the chunks associated have vector close to our query, so it is related to the same topic. So this is how I do that. I define a function. I use my embedding function here, and I use my database chroma, and I need to check the similarity between my query text and all the vectors stored into the database. And after that, I create a context. I also need a prompt. So the good practice here is to create a prompt template, and we use chat prompt template to change the context and the creation here. After that, when you have your prompt, you will have a prompt with the query and the context, and you just need to give it to the LLM, which is Gemma. Here I use Ollama to just run my Gemma LLM locally, and I just use to invoke the model with my prompt. And when you do that, after you can do whatever you want. Okay guys, so it's the end of this video. I hope you like it. Don't forget to subscribe to this channel and don't forget to connect with me on LinkedIn. Leave a comment below if you have questions and see you soon guys.